So this is P18I13. So the change that I've made here is I printed out some servo arms. Let me lift this up so you can see it. And I was actually kind of impressed with being able to get it on there for just a little thing I found on Thingiverse. It didn't even print out the gearing, but it was just the right size so that it what's the word I'm thinking of? It basically created its own gearing. It cold extruded the gear shape onto it. It was just a little bit smaller than the actual gear, and so when it pressed into it, it formed the gear shape. And so this arm is about 1.5 roughly times as long as the other arm I was using. And so where the other one was probably about 1 inch, this guy's more about 1.5 inches. And you will see how it affects our performance. Let me move this back here so you can get a good look at how it does. So that's at 0 right there. And I'll hold on to this guy so he doesn't move. So that's all the way up, and that's all the way down. And I can pull out my angle guy. So my guess is that's something more along 15 degrees right there. That looks to me like 15 degrees. So if we hold it right there, I guess it's, let's see. Yeah, it's somewhere around 15 degrees. And then if we deflect it all the way down, see, notice that did have a problem with fighting the servo. So the servo definitely is a little bit weaker. So here's the main line again, and that's probably somewhere around 15 degrees. I'll stick it on auto for you. Once again, this is where the flap cord fraction will actually start on the real guy. So I think if we end up needing to do a 1.5 length servo arm, if the servo is able to power this much with aerodynamic loading, I think it should be fine deflecting the geometry. And you can see that bump, and that's just because the geometry is a little bit funky, and so it's kind of digging into the floor. So anyhow.